Dr. Madhavan, sir.
Yes, ma'am.
Sir, can you hear me?
Yes,
Dr. Sudhakar, sir?
Yes, ma'am.
Yeah, sir. Shall we start this session, sir?
Yeah, yes, ma'am. Please.
Okay, sir.
nice.
Dr. Madhavan, sir, shall I start the session? Okay.
Start live streaming. Go live.
Shivakumar, sir?
It's live now. Start now.
Good evening to one and all. I am Dr. S. Anbarasi, Associate Professor of EEE Department, PSR Engineering College. On behalf of our college managing trustee, our beloved correspondent, Thiru R. Soleisamy sir, and Director, Engineer Mrs. S. Vigneshwari Arun Kumar Madam, Principal, Dean, Head of the Department, and the faculty members of EEE Department, I welcome all for the one-day webinar on Advancement in Solar PV and Thermal Technologies for Power Generation. Dear faculties, the live streaming of today's session can be seen on YouTube using the link provided on the chat box. I am repeating, the live streaming of this session is available on YouTube. The corresponding link is available in the chat box. Participants, you can encourage your students and colleagues to access this session via this link. And I request all the participants to mute to facilitate the session. To avoid unwanted interruptions, the chat box is muted now. It will be enabled once the session is started. Dear participants, you can post your queries in the chat box during the session. If you want to interact with the resource person, you can also raise your hands. We will unmute you one by one at the end of this session. Kindly don't post any greetings or affiliation details in the chat box. The e-certificates will be issued to the participants, only those who are filling the feedback link that will be displayed on the chat box at the end of the session. Dear I request Dr. K. Punitha Madam, Professor of our department, to give introduction about our resource person for today's session. Dr. K. Sudhakar sir. Welcome, ma'am.
Thank you, Dr. Anbarasi, ma'am.
Thank you, ma'am.
Good evening to one and all. I am Dr. K. Punitha, Professor EEE, PSR Engineering College, Sivahasi, having 15 years of teaching experience. I am profusely overjoyed to take the opportunity to introduce our chief guest of this evening. On behalf of PSR Engineering College Management, faculties and participants, good evening and welcome you, sir. Our chief guest, Dr. K. Sudhakar, is a senior lecturer at the at the Faculty of Mechanical and Automotive Engineering Technology, University, Malaysia. He is also a visiting faculty at Saudi Ural State University, Russian Federation, and visiting researchers at Trong Duc Tang University, Vietnam. He obtained his BE in Mechanical Engineering from Government College of Engineering, Chellam, Madras University, and MTech in Energy Management from School of Energy and Environment Studies, Devi Agalya University, Indore. He obtained his PhD from National Institute of Technology, Tiruchirappalli. He has been actively involved in the teaching and research in the area of energy and environment. His primary research areas includes exergy analysis, energy conservation, climate change, carbon sequestration, biofuel, solar thermal and PV system, sustainability assessment, hybrid electric vehicle, energy modeling, food water energy nexus. He has published around 150 research papers, both in refereed indexed international journals and conferences proceedings. He has authored more than 10 technical books. He is a certified energy manager and auditor by Bureau of Energy Efficiency, Minister of Power, Government of India. Once again, welcome you, sir, and hand over this session to you, sir. Please share your screen, sir.
Yeah. Yes. I hope I am already sharing my screen. So very good evening to one and all. I'm very thankful to PSR Engineering College, Sivagasi, as well as the audience who are present here to listen to this seminar on advancement in solar, thermal and PV technologies, especially for power generation. And also to the audience from all the places, especially from my institute, as well as participants from various engineering colleges. Very good evening to one and all. Today I'm going to present something interesting, especially in the field of thermal systems as well as solar thermal systems and photovoltaic systems. That is what I was planned, and already Madam has given an introduction about me and about my area of research. So I think I'll not take much time in describing myself. I'll directly go to my slides. So I just want to start with this slide. Three global leaders who talked about education. This is very important sayings which I always try to present it wherever I go. Education is the most powerful weapon which you can use it to challenge the world. And when educating the minds of youth, we must not forget to educate their hearts. Anyone who stops learning is old, whether at 20 or 80. Anyone who keeps learning stays young. The greatest thing in life is to keep your mind young. I hope the seminar would keep your minds and hearts young and enlightened. With this, I'll go to my slide. I think I'll skip with this slide. Madam has already given about the introduction. I straight away go with the topic of the presentation with a small introductory note about the energy needs in India, whether energy is going to determine our future or not. So you know all that we are the fast growing economy in the world. Next to China, we are the fast growing economy. Of course, everyone knows that our economy is quite young and we have a urbanizing population, and the average age of our population is also very quite young. And we're already growing. As we grow, there is always a huge demand in the energy sector actually, and which we are unable to meet the present demand actually. And there is a huge stress on the energy supply and demand, which is creating a lot of problems. And it is expected that our energy demand is going to rise almost 300 times in 2040. You can see this figure, which is taken from a resource. The energy demand since 2000 until this year 2020 is almost increasing, and now it is expected to be around 300% increase by the year 2040. So this demand is so huge that it is going to put so much stress on the energy infrastructure which we have. You all know that our energy infrastructure is totally based on coal-based technologies. Around 70 to 80% of our energy is still coming from coal-based power station, and we do encounter a lot of the supply and demand is not matching, and a lot of power failure, and all these things are already happening, and it is going to create a lot of changes in our system, and we need to modernize our infrastructure, and we need to cope up with this demand. To cope up with this demand, we need to diversify our energy supply. Our energy supply is too much focused on the conventional fuel, especially oil and gas, and though there is a stress on renewable energy to some extent, but I think we need to do a lot if at all you want to move towards a sustainable economy. So, and coming to the energy consumption pattern, as far as the consumption pattern is concerned, it is well understood. Industry is taking the major share. So the consumption by the industry is very huge. Next to that is transportation sector, then building sector, domestic sector cooking, and then telecom, pumps and tractors. These are all the major energy consumption sector. The energy is a major source. And next to is the building. And in India, there is a plan to develop a lot of buildings. And in future, there will be so much thrust on having individual households to every middle class individual. So there will be tremendous growth in energy consumption, especially in the building sector. Also, there will be a growth in industrial sector as well. These are all going to create a huge demand for energy. And of course, if there is a good demand for energy, naturally there should be a good supply of energy as well. So for that, we need to diversify our energy sources, and let us see how diversified we can go with all the existing resources we have. As far as the diversity is concerned for distributed power generation, as of now, we are totally dependent on two types of fuel. One is non-renewable fuel, another one is renewable fuel. In non-renewable fuel, we are mostly concerned with diesel, natural gas, kerosene, etc. And they are mostly used for either in the engines or it can be used in microturbine. This is basically non-renewable based. As far as the renewable based is concerned, we have solar, wind, biomass, hydro.
Sir, can you hear
yes,
me, sir? Sorry for the interruption.
Yeah.
Are you sharing your screen, sir? Slide?
Yes, ma'am.
But your slide is not visible, sir. Your video only visible. Can you please check it again?
Okay.
Sorry for the interruption, sir.
Is it visible now, ma'am?
Now your desktop is visible, sir.
How about the slide?
Yes, sir. Slides are visible.
Okay.
Yes,
okay.
Sir.
I'm sorry for that. Let me just quickly go into the
no issues, sir.
slides.
You can continue. Thank you, sir.
So this is about the energy demand. You can see this. Share. I said almost 300% going to be the increase in the energy consumption. And this is about the profile, the energy supply demand profile. You'll see the industry is going to take the major share. Next to that is transportation and building. So there will be huge demand in the industries, buildings, and transport sector. And as far as the distributed power generation, we categorize into non-renewables and renewables. And in non-renewables, mostly this diesel, natural gas, kerosene, coal, this is going to play a role. And renewables, it's mostly wind, solar, hydrogen, biomass. All these technologies are available. And what are the clean technology options we have? Let us discuss one by one. Either we can go for energy efficiency system. It is also considered a kind of a renewable energy. People may not very much concerned on energy efficiency. Energy efficiency is one good options we have. Green buildings, smart grids, and then environmental technologies. We have mostly, we can focus on waste management, then sanitation, and in clean coal technologies, we can go for coal benefaction, coal combustion, clean coal combustion, coal conversion. That is, you can try to go for coal benefaction and all. These are all the options which we have. And in water management, of course, we need to have a drinking water source as well as wastewater management. These are the opportunities we have in clean technologies. We'll discuss one by one. As far as the future scope is concerned, what are the technology innovation is needed is in these areas. If you want to think about low carbon economy or totally net zero emission sources, there are a few options. Those options are integrated gasification combined cycle, which is called IGCC power plant. Another one is carbon capture and sequestration, where you can capture the CO2 from the thermal power plant. And then the third major option is to reduce the cost of wind and solar power generation. And then the nuclear power technique is also one of the things which are being considered. Alternate fuels, hydrogen energy. These are all the various options if at all we want to go for newer sources. Emerging technologies, all these renewables are emerging: solar, small hydro, bioenergy, wind, geothermal, small thermal sources, hydrogen, fuel cell, energy storage, then hybrid electric vehicle, which I had a presentation day before. So these are all some of the emerging technologies. Let us go into this detail one by one. But among all these options, the topic which I'm going to present today is mostly about solar. And so India has already committed for change. That is almost 175 gigawatt of green power by 2022. This was India's commitment to climate change. In that, there is an expectation of around 60 gigawatt of wind, 100 gigawatt from solar, 10 gigawatt from biomass, and 5 gigawatt from small hydro. This is our India's commitment. And also there was an expected reduction in carbon emissions to about 35% by 2020 from 2005 level. This is one of the emission targets which we have set forth. And also create carbon sinks to capture the CO2, that is almost 2.5 to 3 billion tons of carbon equivalent to be sequestered through adding forest and tree cover by 2030. And then also adapting the climate resilient agriculture and water conservation. So these are some of the India's nationally intended contributions. Of course, we are very close to this 2022. I don't know how much we are going to achieve by the year 2022, but I think we are almost running close to this target. And regarding solar, we need to understand about the types of solar radiation. So in this, we categorize the solar radiation into three categories. One is called direct normal irradiance. Another one is called diffused horizontal irradiance. And the third one is called global horizontal irradiance. By seeing this picture, you can clearly understand the direct radiation is nothing but the energy which comes directly from the sun without undergoing any scattering from the clouds and other things. That is called direct radiation. And direct radiation plays a very, very important role in selecting the sites for concentrated solar thermal power plants. So for that, we are very much, we should be concerned on the direct solar radiation availability at a particular location. And diffuse solar radiation is nothing but the energy which is getting, the solar radiation which is getting absorbed, scattered by the clouds, and then when it is reaching on the Earth's surface, this is nothing but the diffuse solar irradiance. For example, on a cloudy day, on a very dull day, you can see most of our radiation is coming from the diffused radiation. On a hot sunny day, most of our radiation comes from the direct normal irradiance. And this global is nothing but the direct plus diffuse is considered as a global horizontal irradiance. Whenever we want to assess a site for a solar power plant, we should be very much concerned about the availability of D&I or CSP plants. And whenever we are very much concerned to put a solar photovoltaic power plant, we should be worried about the GHI. How much is GHI is present in a location? It is nothing but the sum of D&I and the diffuse solar irradiance. This is being considered for the selection of site for a photovoltaic power plant. Normally, the energy from the solar can be utilized in two ways. I am calling this as a power generation. Normally, we call it as utility scale solar electric power generation. So because whenever we say utility scale, it is all about large scale infrastructure. So large scale infrastructure can come through solar photovoltaic route as well as through solar thermal route. In solar photovoltaics, we directly convert this sunlight into electricity directly without any moving parts or something like that. So that's why the solar photovoltaic is a very, very simplest way of generating electricity. Whereas in the thermal route, we of course use a mechanism to produce first heat. The mechanism may be a concentrator or a mirror or something like that. We concentrate the heat and then This heat is being used to produce electricity. This is to some extent a indirect form of generating electricity. So mostly the solar thermal route is considered as the indirect form, whereas the solar photovoltaic route is considered as the direct conversion of electricity. So you see the cycle through solar photovoltaic, it's very direct conversion. It's going to be much easier than solar thermal route, because first you need to produce heat, and then converting heat into electricity is also another route. So therefore it takes some portion of losses and all these things. So I'll come into this detail later on. As far as the direct route and indirect route is concerned, how we can use this heat also. This heat can be used in several ways. Normally this heat can be used for space heating, water heating applications. Sometimes it is also used for cooling, especially refrigerations and all these systems. Solar cooking is one of the way in which we can use this heat. Industrial process heat is one of the major applications. Many of the industries needs process heating for their process. So in such places, this solar thermal heat can be used, and then the solar thermal electricity, and then this one other important thing is the solar hydrogen, which is used to produce fuel. So we all know that the sunlight can be used to produce heat. Sunlight can produce fuel. The sunlight can also produce electricity. That is what I want to say from this slide. So we got three things from solar energy. You can produce heat, that is the thermal energy. You can produce the fuel also. How to produce fuel, we'll discuss in detail. And this fuel, subsequently, how it can be used for power generation also, we'll discuss later on. And then our major thrust will be on solar thermal route and solar photovoltaic route. Of course, I'll touch little bit on the solar fuel route also, how to produce solar energy for hydrogen production, and how this hydrogen can be used in your vehicle also to some extent. So overall, we'll be going to discuss all these things and some innovative applications in the field of solar. All these things we're going to discuss. As far as the strategies for power generation, you can have a look into this slide. It gives an idea about how to generate power from solar. There are very complex routes for this. Let us go to this different route. Straight route, the direct electricity route is very easy. That is through photovoltaic device. We produce power and then it can be utilized. So this is the direct route through the PV. The next route is, sometimes the sunlight is not sufficient. It is very dilute. It is not concentrated. So we use a lens or a mirror to concentrate the light. And then we go for optical concentration method. And then we use it as a device called CPV, which is called concentrated photovoltaics. And this concentrated photovoltaics can be used to produce power. This is another way. And the third way is through the heat generation. Sometimes the thermal radiation contains mostly heat. So this thermal radiation can be used as an emitting source. And this thermal radiation can be used for, this all application is already being discussed. But this thermal radiation, which contains photons, can be used in a thermoelectric device, and this thermoelectric device can be further used to produce electric power. So basically, we have two additional routes in the thermal side. One is concentrated photovoltaic, another one is called TPD, which is called thermoelectric device. These two are called as, one is called as STPV, another one is called STE. And the third one is CSP. Of course, it's concentrated solar, where we concentrate the light to produce heat, and then we use a steam turbine to produce electricity. So these are the various modes of power generation. Let us go to in detail about each technique, how to produce power, especially with all these methods we have. Regarding the concentrated solar power, you need to see the availability of direct normal radiation. If you see the figure, if you see this map of global solar map, you will come across this profile. The places, the regions where with little annual cloud cover with a DNI exceeding 1800 kilowatt hour per meter square per year are very much suitable for CSP power plants. You can see this scale. In the scale, you can see the yellowish color. From yellowish, there is 1800 to this dark regions. These all dark regions are very much suitable for for CSP. You can see this parts of US, and here in African region, you can see the Arab countries. In India also to some extent CSP is good. Then Australia, and then some part of Russia. So these are all the regions which are suitable for concentrated solar power technologies. And coming back to our country, the DNI and GHI profile of our country is shown here. The first map talks about direct normal irradiance. So here you can see parts of Rajasthan, Gujarat has got a very good DNI, and to some extent in some patchy areas in MP and some parts of Andhra, Tamil Nadu has also got some potential for CSP technologies. And then of course Jammu Kashmir and other areas to some extent also possible. And this is about the GHI map. Of course, the whole country is suitable for solar PV installations, except few parts of Northeast and Jammu Kashmir. The whole country is suitable for solar photovoltaic power. Utility scale power generation. So we are talking about large scale. Therefore, I'm going to use a word called utility scale. In utility scale power generation, we normally produce the power, and this power produced is fed into the grid. That is what is called as utility scale. And normally utility scale power plants are in megawatt scale. At least it should be greater than, I'm sorry, the symbol is mistake. It should be greater than 1 megawatt. Such power plant are considered as utility scale power plant. So the utility scale power plant has got its own advantages and disadvantages, which we'll discuss later on. But to define the utility scale, the capacity should be greater than 1 megawatt. And as far as the site selection criteria is concerned for CSP, you should have a huge land area. That is the major problem with CSP technologies. We need at least 5 to 10 acres of land for 1 megawatt of solar capacity. That is with a very limited cloud cover. The cloud cover should be very less. The DNI should be very good. And if at all you want to build the CSP tower cost effectively and efficiently, it should be built in size of at least 100 megawatt or higher. You just see for 1 megawatt, we need roughly 5 acres. And if it is for 100 megawatt, you just multiply, you see how much acres of land, 500 acres of land needed for megawatt capacities. So 100 megawatt, if you plan, that would be more cost efficient. That would be more efficient as well. And it accommodates thermal energy storage. Normally, CSP plants comes with a energy storage device. That is a major issues with the major consideration when you select a site for concentrated solar thermal power plant. Then access to water resources. Like a conventional coal-based thermal power plant, we need huge water for its operation. Water is needed for cooling as well. Sometimes water is needed for cleaning and cleaning the mirror surface, etc. Also need for cooling techniques and all. And then we need to have access to the transmission network, because our transmission network should be closer so that there will be no distribution or transmission losses. So the proximity to the transmission network is one of the major factor while considering the CSP power plant. Also, access to the high voltage transmission lines is also a very key factor. Because you want to transmit the power to the end user. So therefore, these are all the factors which you need to consider if at all you want to locate a CSP plant. One major issue is I talked about the land, which is around 5 to 10 acres of land per megawatt. So this is a major issue with the CSP technologies. As far as CSP technology is concerned, they normally categorize into four technologies. This is a parabolic trough technology. This is linear Fresnel system, and the third one is parabolic dish, and then this one is a solar tower concept. So normally these are the four standard configuration we use for power generation. Each one has got its own advantage and disadvantage, which we'll not discuss in detail. And among all this thing, this solar tower concept, it uses heliostat mirrors to reflect all the sunlight to a particular point where boiler, observer, everything is placed, and then which executes Rankine cycle. So here, in case of dish type, we use a Stirling engine to produce power. So each one has got its own problem and advantage and disadvantage. This is a typical photograph of all these technologies. You can see this solar tower concept. So huge heliostatic mirrors are being arranged, and this is being used to focus the sunlight at a particular point, and then have a huge parabolic trough mirrors, which are being used in the case of parabolic trough technologies. Case of Stirling engine, we use this dish type collector, and then it focuses at a point, and then an engine is used to convert this heat into electricity. And then linear Fresnel is another concept. So these are the photographs by which you can understand how these systems are working. All these systems needs heat, and then a kind of a liquid which uses this heat. Normally, the steam is used to run a turbine. So in that way, these all systems, it almost like a conventional thermal power plant, except the heat is through the solar, concentrated heat from the solar. Major issues, optimization of power supply for power generation. The major is you need to have a adequate amount of water in that region. So if you don't have sufficient water, then I think it will be a big problem, especially parts of Rajasthan. There is a huge shortage of water. So you need to have a regular supply of water for power generation. The turbine efficiency is major issue due to the low quality of steam which is being produced. And then availability of power grid at the vicinity, that is a problem. Land availability, as already pointed out, in a country like India, where it is densely populated, and we may not have enough land availability. So that is, if you want to construct in utility scale, actually we talk about large scale power plants. In that case, you may have a problem because you may not have enough land to construct a megawatt scale plants. So this land availability is a concern. Poor infrastructure in remote deserts for material transport and habitat of workforce. But sometimes in remote regions, we don't have transport facilities, and there will be no habitat for the workforce aspect. So these are the problems if you construct these CSP plants in remote areas. And normally CSP is promoted as an urban energy source. It is not considered as a rural energy technology. But most of the CSP technology is actually located in rural areas, in very far away remote locations. Therefore, it should be promoted as a rural technology than the urban technologies. Also, CSP should be used to finding solution for drinking water in coastal region through desalination. Of course, this is one of the another area which we need to focus. How CSP can be used for power generation as well as for tri-generation. There are new concepts coming like poly generation, tri-generation, something like that, where we can produce electricity, can produce heat, you can produce cooling, also you can produce water for drinking. So these are all options we have when you have the CSP technology. Tri-generation and poly generation can also be coupled with this kind of system, which are also being considered, but these are all complexity involved, major issues involved with the CSPs. We just discussed now about the positive impact and negative impact of these technologies. The positive impact is very well known. It's reduction of greenhouse gases and other toxic gases. And sometimes the arid land, which is not usable for agriculture, the degradable land can be used, and increase energy dependency at national and regional level. So in that way, we are secured with energy resources. So we need not depend on other country for other things if we are able to generate energy with this CSP technology. And energy diversification, energy security. Sometimes it helps in rural development and also provides jobs for us, especially solar jobs and all this thing. It reduces cost of transmission line, and sometimes it can be integrated with the building envelopes. It always comes with some negative impact also, because sometimes agricultural lands are being used for power generation, which is not good. So we need food. Food is a very important thing. Then comes the energy. So this food, water, energy nexus is also we need to discuss. Sometimes these three terms they are very much related to each other. Energy is definitely a commodity which is very much needed, but it should not come at the cost of our agricultural resources. Therefore, it may have a negative impact on utilization of a valuable agricultural land, where the food yield and food productivity may be affected. That is one major impact we have. Impact on the ecosystem in the case of a large-scale solar system, because these are all huge concentrating mirrors and all this thing, and it is going to produce too much of heat, and this heat is unbearable at the locality, and sometimes there is a threat to the local ecosystem, especially the wildlife and the plant life, all this thing near to the power plant area may get affected. Loss of visual facility. Sometimes these lights, when gets focused, this will create a huge visual impact. So this is loss of vision and other things. So the employers are all to be very careful when they work in this kind of environment. Sometimes there is accidental release of chemicals into the locality, especially in case of CSP plants, because there are thermal storage and other chemicals which are being used. Therefore, there is a chance, there is an accidental chance, but however we take preventive measures, this may not be an issue. And there are very occupational hazards because we deal with the high temperature, we deal with the chemicals also. Therefore, there is some occupational hazards during operational and construction as well as maintenance time. Large-scale solar power plant may impact the wildlife as well as the habitat. As I said, it may affect the ecosystem as well. Impact on the ecosystem may include flora, fauna, birds, insects. All these lives may get affected. So these are the problems with the. I have not gone into the PV technology so far. These all impacts are specifically for the solar thermal technology, which is concentrated thermal power. So these are the problems which we may encounter if you have these systems. You can see a picture which talks about the cleaning of the reflectors and mirrors. So it needs huge water. This water resource should be optimum, should be available at the site for cleaning the mirrors and reflectors. So this is a major issue because it needs a lot of water for cleaning, cooling systems and all. And this is also a cleaning. This slide talks about the cleaning mechanism, though it talks about PV. Cleaning is also needed in PV technology also. The mechanisms, there are various mechanisms. You can go for a hand cleaning, but it takes a lot of time by doing the manual cleaning process. You can go for a vacuum cleaning. Sometimes the mechanical method of wiper brush is being used with automated systems. Robot cleaning is one advanced technique which is being used to clean the modules. Of course, these all techniques for PV panel, not for the concentrator power, not for the reflectors. One recent trend in the concentrated solar power technology is integrated solar combined cycle power plant. I don't know how many have heard about it. It is typically a gas turbine power plant integrated with the solar thermal concept. So in the solar thermal concept, we use a huge parabolic systems to produce heat, and this heat is used to convert, and then this heat energy is used to produce a kind of gas, syngas, something like that, and then this gas is used to fed into a gas turbine, and this gas turbine undergoes a Brayton cycle, a conventional steam turbine cycle. So this is a kind of integrating the solar with the combined cycle power plant. This may be a solution for existing thermal power plants, but again, we'll discuss what are the problems with this advancement, especially with the integrated solar combined cycle power plants. The problems are the limited international experience. So our experience with this plant is very less, and our coal is low ash coals, so therefore it may have a problem with integrating with this technology. And this fluidized bed gasifier considered suitable for Indian coasts are not proven internationally. This particular fluidized bed gasifier is not proven internationally. Of course, it comes with a very high capital and operating cost. So this is a major issue with the integrating the solar thermal system with the gasifier based combined cycle. And then the Indian coal requires indigenous developments. We cannot use foreign technologies to implement in our condition, because our coal is totally different. It will have high ash and high the lignite content. All it is a very worst form of coal, and this coal may not be useful to be used in this kind of plant. So this is a major problem with this. And some studies have been carried out by Nexent USA and BHEL, which indicates that this technology is low efficient, and then the availability factor of this plant is also low. So there are some few findings, but I need to do a lot of more analysis, cost analysis, performance analysis to know really whether IGCC cycle would be the part of our energy generation or not. And I said regarding the power generation, we just talked about CSP. And let us go and discuss something about thermo-photovoltaic system, thermo-photovoltaic. In thermophotovoltaic, if you see the figure, we normally use in between a kind of a thermal emitter. This can be any source, any thermal source which produces heat can be used, and this photons is again used in a photovoltaic diode cell. Basically, here any thermal source can be used to this heat can be used into a thermo emitting sources, and then can be used in a solar cell and produce electricity. So first is basically direct conversion from heat to electricity via photons. The photonic energy from the thermal source is being converted into electricity through PV route. So basically, it's a combination of we call this as a thermo-photovoltaic device. Basically, it doesn't have no moving parts. It requires less maintenance. It can be used for remote site and portable electricity generation. A lot of research is going on this, how to increase the system efficiency and how to keep this performance better. There are some research going on. It's a new topic, thermo-photovoltaic systems. Also, there is a concentrated photovoltaic system. So this concentrated photovoltaic system uses a kind of a concentrator mirror, like a CSP. We use a concentrator lens or a mirror to concentrate a light on a solar photovoltaic device, basically, and then we can produce more electricity. The efficiency is expected to reach something around 40%, and basically this kind of system are very much suitable for regions which is having a high DNI availability. Those areas are ideally suitable for this concentrated photovoltaic system. And there are some companies which have tested this in a large scale. And in our country, there are a lot of work going on at the laboratory scale and utilizing the CPV technologies. Solar thermoelectric generator is also an upcoming field. Here it involves direct conversion of heat flux into electricity through Seebeck effect. You all know Seebeck effect. Whenever there is a temperature difference between two dissimilar metal, it can produce a voltage. So similarly, exactly this, we maintain two different material we try to maintain at two different temperature, and this two different temperature produces a kind of effect, the Seebeck effect, which is used to produce electricity. So this is a solar thermoelectric generator. These electric generator also can be coupled with the solar PV systems, because normally solar photovoltaic device also produces thermal energy, and this PV, the thermoelectric device, can be coupled with the solar PV to produce electrical power, so that the efficiency can increase. Normally the efficiency is around 5 to 8% for the solar thermoelectric generator, because the power generation and the temperature difference is quite less. But if you can scalable to any size, this can be scalable to any size. It will have a lower operational and maintenance cost, and it is this growth of this thermoelectric generator is also going to increase in the coming years. And so far we discussed about concentrated solar power for thermal generation. Now we pass on to the solar, how the solar energy can be used to produce fuel, and then at last we go for the solar PV aspects. What are the new applications in PV? As far as the solar energy, this can also be used to produce fuels also. The interesting fuel which we can produce is hydrogen. And hydrogen can be produced in many ways actually. One is through the thermochemical route, using this metal oxide cycle, which is a chemical process. And then there are another route which is through the known route, like electrolysis, photolysis. All these routes are available, and these routes can able to produce hydrogen. And this hydrogen, of course, can be used in a fuel cell car. It can be used as a future fuel, or also can be used in a fuel cell to produce electricity. So in that way, this hydrogen will have a multiple application. It can be used for not only as a fuel, it can also be used as a electricity source through fuel cell. So basically, the solar energy can help in producing hydrogen also through these several routes. I will not go into the detail of each process, but I just want to I want to highlight that how solar energy can be used to produce fuel as well. That is what the slide is being shown here. However, this topic is not of interest at this moment, as we are mainly concerned about power generation. And this slide talks about the efficiency of hydrogen production through different routes, through electrolysis route, through the hybrid sulfur route, on all these routes, the annual efficiency will come around 13 to 25% is the production efficiency of hydrogen through this all process. Of course, these efficiencies are quite low. So there are many techniques in which we can optimize this efficiency by improving the optical efficiency, receiver efficiency, all these methods through which we can optimize the hydrogen production. Of course, when you use this hydrogen again in fuel cell and then in the engine, then we need to think about how much efficiency we produce at the end user side. So this is a major challenge. So let us see how this slide talks about how hydrogen can be used in a car, in a fuel cell based car, as well as how solar energy can be used to power a vehicle also. We used to think that solar means can produce only electricity. So we never thought solar can power a vehicle. The solar car is quite a research topic, but through a hydrogen route, let's say we use the solar energy, produce electricity, and then the electricity is used to split water into hydrogen, and then this hydrogen can be stored and then distributed, and then this can be used in a fuel cell based car. So this is a route which is being talked these days, how solar can be used in a fuel cell car, solar powered fuel cell car. And of course, the direct way is having a solar photovoltaic system on the roof of the car and produce electricity, and then this electricity is to recharge the battery, and then the battery is used to run an electric motor. So this is a standard route, and this is another route in which you can produce hydrogen and then use the hydrogen in the fuel cell car. So this is the way in which we can use the solar energy to produce fuel as well. This picture talks about a solar powered car. So basically, it's kept on the roof of the car itself, and then in the daytime you are able to produce electricity and then store it in the battery, and then you can use it to run this car. There are a lot of work done by a lot of universities. Sanswift 4 is the latest solar car, which are built by the students of University of North South Wales, and they are made with the low weight batteries. Also, this photovoltaic cell with high efficient solar photovoltaic cell is being used for this application actually. And this slide talks about what are the various advanced material which is used for renewable energy. Basically, all this solar conversion takes place with material. Without material, this solar conversion cannot take place. So let us see what are the material being used. Of course, I covered other renewable also in this slide, but we specifically will focus on the photovoltaic cell material and then the concentrated solar material. So in this, the latest trend is about perovskite material, quantum dot, all these things are being researched, all nano solar cell based technologies. In concentrated, mostly these days polymer substrate coated with aluminum, all these things, lightweight material is being researched for concentrated solar power. In fuel cell, there are new electrolyte mostly researched. In hydrogen production, is a metal oxide framework, metal organic framework, MOF is being researched. In carbon capture, again, all nano-sized catalyst for absorbing material. And then in biomass and all algae-based genetically modified systems. So these are all being researched. In wind power, composite materials are being researched for alternate things. So some material aspects also coming into picture whenever we talk about photovoltaic conversion or thermal based conversion. It all involves materials actually, material aspect. Now we'll go to the solar photovoltaic route, which is the simplest route for electricity generation. And in the solar photovoltaic route, there are basically 4 generations of solar cells which are being used for power generation. It starts with the first generation. Mostly the first generation solar cells are crystalline based silicon solar cells, which is made up of single cell or multiple crystalline, single monocrystalline cells or multicrystalline. The second generation is mainly focused on amorphous based silicon, cadmium telluride, and cadmium indium arsenide, all this one. And then the third generation is basically focused on dye sensitized solar cells, And then photoelectrochemical solar cells, all this comes under third generation. Even multi-junction is being considered third generation. And then the new generation, which we are currently working on, it is the latest one, which is mostly nano-based solar generation, which is perovskites and hybrid, which is organic plus inorganic combination is being researched, which is fourth generation solar cells. As of now, the commercially available solar cells are coming either from the first generation, second generation, or third generation. The fourth, first and second generation. The third and fourth are still maybe at the research level or still not reached into the market actually. Nanotechnology is playing a vital role in the solar cell development, because the efficiency of solar cells currently are in the range of 15 to 20% roughly, and then they are trying to optimize the efficiency and come up with a low cost alternate material, because in the conventional solar cells mostly we dependent on silicon based material, which the conversion process is very energy intensive to produce a pure crystalline solar cell from the silicon is a very energy extensive process. If you do the life cycle analysis of electricity from the silicon based solar cell, it may not be good actually. So therefore the alternate is being researched. The alternate is purely nanostructure based. We use organic based nanomaterial based with dye sensitized, in the sense organic based dye is being used for electrolyte and all. So a lot of research each involves nanotechnology. This nanotechnology is being used for efficient solar capture as well as for solar storage also. Ultimately, the objective is to bring down the cost, also to bring down the size of the solar photovoltaic systems. Perovskite solar cell is the latest one. Normally, the efficiency of solar cell in the range 16 to 80%. And normally, they say the theoretical limit of the silicon efficiency is around 29%. There are some studies which shows that perovskites can go to reach around 35%, as high as 35%. But again, these solar cells have a problem, mainly related to the degradation, cell degradation, and then the reliability, durability, and stability of these devices are not proven yet. So therefore, these solar cells have to they are currently facing these difficulties. We need to come up with some solutions, and there are a lot of publications and papers on the perovskite solar cells. A lot of work is going on. So the highest efficiency so far reported is 35% efficiency has been reported. One of the important advancement in solar cell is the flexible solar panels. These are all carbon-based, graphene-based solar cells. These advantage of these solar cells are, it looks like a very thin film. So what you can do is you can just paste it on a surface. It can be placed on any surface. It can be wound. It can be rolled. So it will look like almost like a piece of paper. So this is the advantage. And these are all also transparent also. So the advantage of transparent is it can allow light to pass through, and the capture efficiency is more. So in that way, it will be flexible, it will be low cost, transparent, and it can turn any surface into a source of electric power. So that is a major advantage with this flexible solar panels. And imagine a future where the solar cells will be everywhere. It will be on your walls, it can be on your windows. Already it is in our mobile phones, laptops, and many more devices, many more portable devices. You can find these kind of solar cells in future. Coming to the large scale power generation, the types of installations, how do we install solar PV? Normally, the ways of installations are ground mounted systems. Sometimes it's our roof mounted. There sometimes canal top, offshore floating solar. So in that way, we can mount these solar PV systems. The large scale solar PV systems are either comes under any of these categories. It can be roof mounted, ground mounted, and all. So far, the utility scale power plants are all ground mounted systems. They are called as conventional solar power plants. Rooftop power plants, which may be grid connected or standalone systems. These kind of rooftop systems or distributed power systems, especially at your household building, can be used for rooftop. Canal top, we'll discuss how canal top systems are being used, offshore, and then floating. We'll discuss all these installations one by one. Ground mounted is the most common. You will see these ground mounted systems where the PV device are mounted at an angle which is almost plus or minus equal to the latitude of the location. And this normally uses racks or frames attached to the mounting support actually. And these systems are either fixed or it can be a tracking mechanism also. It can be a single axis or dual axis trackers. But if you use trackers, it is going to be expensive. You need a complex motors to track the sun and all. Electronic systems are being used. Normally, the ground-mounted solar power plants are fixed at a particular angle. However, we can tilt this angle according to the location, according to the season also. There are some analysis in which we need to slightly tilt the module according to the season to increase the power generation. So this is a ground-mounted system. Normally, conventional power plants work on this ground-mounted system. Rooftop system, you all know about it. So our building can be used to generate power. So basically, it is also called as a BAPV. Short form is building attached photovoltaic system. Building attached photovoltaic system, where your rooftop can be used for power generation. It can be either grid connected or it can be a standalone system. But if a standalone system, it needs battery for energy storage. If it is a grid connected, grid type, it doesn't need battery. And normally any rooftop with inclined surface or with enough rooftop surface can be used for power generation. This is a rooftop based projects. Canal top systems. So you will see in India is full of rivers, canals. Wherever you see canals are very quite common, and these canals, water flows into the canal, and only problem with these canals are they are irregular in shape. If the narrow canals are there, if they are very straightforward, and the solar PV systems can be covered on the top, and then it helps in minimizing the water evaporation, and it helps in generating more power than the land-based system because of the cooling effect beneath the surface. At the same time, you can reduce water evaporation, and you can use this canal for power generation. But major problem with these canal systems are sometimes these canals are being used for transport purpose. Sometimes it is being used for navigation, moving from one place to another place. Especially villages used to cross this river through the canals. Therefore, the access to the canals is being denied for the farmers. This is one major problem with the canal top systems. And these canals are irregular in shape, and therefore there will be problem in installations because your supporting frames and structure should match to the canal. The canals will be curved, sometimes straight, sometimes it will be like a different shapes. No, accordingly, you need to have the structures to mount these solar PV systems. So in that way, it is facing some problems in the installations. There are studies which shows that efficiency and power generation is much better than the rooftop as well as the ground-mounted systems. Offshore systems, you all know have a very large coastlines we have. Of course, the major problem with these coastlines are whether this water body belongs to us or this water body belongs to other country. That is a major problem we face if you go for offshore. If you want to put solar on the ocean, we need to know whether this ocean is owned to us. Within our oceanic boundary, we can go for such installations. Again, but this offshore environment, you can go for island-based, Lakshadweep, Andaman Islands, and all Nicobar Islands, which are part of our ocean surface can be used. But problem is, you know about disasters, tsunami, and all these things. So when the huge cyclones and all this comes, and these systems are prone to stability issues, and the structure should be good enough to withstand all these typhoons and all. This is offshore one. And another one will be the floating system. What is the difference between offshore and floating? Offshore is nothing but on the ocean water body itself, that is offshore. Whereas a floating system, it can be on the ocean or it can be on stagnant water bodies. Stagnant water bodies or moving water bodies. It can be on the rivers, it can be on the lakes, it can be on the dams, it can be on any stagnant water surface can be used. So in that is called floating PV systems. We'll go into the detail later on what are the advantages of floating systems and all. There are new ways of using solar PV technology. This picture talks about different aspects. one is photovoltaic, agrovoltaic. Then this one talks about solar roadways. Then we'll go into this one by one about all these new things. BIPV is also one interesting technologies where we can integrate solar directly into the building actually, because this solar cell is going to replace your conventional building material. It is going to replace your cement. It is going to replace your bricks, and then this solar structure is going to act as a building material itself. So in the future building, you can integrate the PV into the building itself. It can, your whole building is going to be a net energy exporter than the energy drawer. So in that way, we can be self-sufficient in power generation. And these PV can be installed on the facades, on the roof, on the windows, on the anything. Basically, the entire building actually can be integrated actually, especially skyscrapers and all these kind of buildings. We can go for power generation. It can reduce in material cost, electricity cost. It can reduce pollution. Sometimes it also increase the aesthetic look of the building. Therefore, BIPV is a wonderful solution. All the future building can be a building integrated PV systems can be there. Solar roof type is also one of the things where you can attach your solar PV cells on the roof tiles, and then it can all the middle class houses can have this kind of structures, and every tile can have a solar panels. Therefore, it can be a totally eco-friendly homes actually. In future, we can have a green homes, and green homes can come either through this solar roof tile concept, or it can come through the BIPV concept as well. One interesting research which we are into it. We are currently working on it. A lot of feasibility studies has been done. In fact, in India, we have a Cochin airport which is totally based on solar power plant. You all know that aviation industry. I'm talking about the aviation industry 3-4 months back. So forget about the aviation at this moment. It is struck due to the COVID impact. But just before the COVID scenario, aviation industry is the most benefiting business. But the problem with aviation is it causes a lot of carbon emissions. To make this aviation industry sustainable, the airports have huge amount of land within their premises. The runway, their zones within the airport can be used for solar installations. Like their open land can be used, their parking lots can be used, and all this thing. We did a lot of analysis, and we found that only major issue with the solar airport-based solar is nothing but the glare which is affected with this particular solar PV panel. So if you see at particular instant of time, these panels will generate glare effect. Even when you drive through your car or something, when you drive in the morning, you can see sunlight glare on your car. So like this solar panels produce glare at a particular time, and this glare happens for a few minutes, or it may happen a few hours. At that time, when the pilot is trying to land, it may cause some impact. It may cause poor visibility, or it may impact their eyes, and it may have a huge impact. It may even result in kind of severe accident actually, because of the glare on the glare inside the airport actually. So this should be avoided. So while designing the solar PV system for airport areas, we need to see glare impact in the airport. We need to see should be zero glare on the surface. There are some software which are available to study how much glare is available at a particular location. So that can be studied in detail. We have this floating solar device, which is a very interesting topic. And India, you have a very good lot of water surface. 70% of the Earth's surface is covered with water, and this floating solar systems. There are a few queries. I think I'll answer at the end of the session. We'll answer all these queries at the end of the session.
Excuse me, sir. Your screen is not visible, sir. Your presentation slides are not visible now.
Okay, 1 minute.
Yeah. Okay, sir.
Now, ma'am, is it visible?
Yeah, sir.
Yes?
Yes, sir.
Yes, sir. Yes, sir.
Okay, so there was a small interruption. So we'll go to this slide. It talks about floating solar system. The main problem is with the mooring system. Actually, if you take a solar photovoltaic device, the floating systems, uh, we need to have a supporting structure and a kind of a mooring system to keep this platform stable. Actually, so this is a major issues with this with the floating solar system. The mooring system or the mounting structure is not like a ground-based system. Actually, it involves a kind of mooring which should take care of the difference in water level. The water level may rise, it may come down. Sometimes there are issues with the water level. Therefore, we need to have a stability issues. So we need to have a kind of a mooring system which will adjust this platform according to the water level. And then we need to have a very good fiber optical based cables which can run through the underground and then and produce the power at the land, actually to transmit the power to the land. So these are some complexities involved in the floating solar systems, mainly with the cables and with the mooring systems, actually. And these floating solar systems are got higher efficiency due to the cooling of the system, which is well known. There is expected there is a 10% improvement in efficiency compared to the land-based systems. We'll go to the next interesting application, which is called agrivoltaics actually. So I just talked about food, energy, water nexus. Sometimes the land is needed for water, the land is needed for energy, need for food is one of the issue. These three words always are interconnected. So energy is definitely a priority for us, but it should not come at the cost of agriculture. Agriculture is very much important. So there can be a synergy in generating electricity and food. One such concept is called agrivoltaics. Agrivoltaics is a perfect combination of solar PV with your farmland to produce food as well. Normally, farmers are struggling with agricultural yield. Sometimes it is prone to lot of damage, or sometimes they don't have yield and all. So if the farmers grow with this kind of technology where their land can produce electricity, and this also can provide shading to the plants which can grow beneath the solar panel. So thereby they can produce good amount of field as they can produce electricity. In that way, the farmers can benefit from this kind of concept. So in that way, this is going to be a very interesting application in future, agrivoltaics. Then going to the one is solar powered aircraft. So this is a very interesting one, but again, so far the successful one is around 66 kilowatt solar photovoltaic technology. So which is being tried by this is the Impulse 1 and Impulse 2 project. If you just Google it, you'll find the detail about it. This was the most successful solar aircraft project so far, and it is weighing about 2.3 tons, and roughly it can travel at 70 kilometers per hour, and it is housing around 17,000 solar cells on its roof. So this is an achievement so far in this field of solar aircraft. So it can power an aircraft as well. So but you need more amount of solar cells, and it occupies slightly larger surface than the conventional aircrafts. So this is the one interesting application. Then we'll go to the next one. So how many of you have heard about solar fabric? So in future, our shirts or t-shirts, our fabric can generate electricity as well. So there is an interesting application called solar fabric in textile industry, and it can be a part of our clothing itself. Basically, it is made up of polymer fiber with a lightweight and low-cost material. It can be embedded into a t-shirts, your winter coats, and it will be flexible to wear. Like we are wearing this coats, this can be replaced with your fabric, which can generate electricity also in the sunlight when you walk and when you wear it, or when you wear it at your office, it is going to generate electricity. It can be useful to power your mobile appliances. So this is one interesting application. Hope we will have such bags in future. Maybe our curtains can also generate power for our homes. So this would be a future opportunity for women entrepreneurs, where they can stitch fabric which can produce electricity. And then solar PV tent. So you will see this kind of applications in remote areas when you go for camping. Suppose you go to a forest and you are doing a camping in a remote locations. Let's say you go for a trip in Kodaikanal or Ooty and other regions. You want to construct a tent. This kind of things will be useful to meet your emergency electricity requirement, and it can act like a home also. It's like mainly this PV tent is used for camping purpose. It also used for electricity, which can be fed into the grid also. This is a very interesting one. Solar PV tent, solar backpack. You will find a solar cell attached to your backpack itself. You see a lot of people who are backpack holders who travel a lot to many countries, and these people can use this solar backpack, which can use to power their batteries and USB port also. So this is a very interesting one, backpack one. And solar trees actually. So this is like mimicking our natural trees. Solar natural trees is like which is used for producing. It is this tree replaces a conventional tree with the solar panels. These days we use a 3D printed panels. 3D printed panels means a little bit flexible enough, which can be constructed in the form of a tree, and then this can produce more of electricity than the normal flat plate PV systems, because this flat plate one occupies a lot of land and all this thing. So if you can arrange this PV material in the form of a tree, it can occupy less land area and it can produce a lot of additional energy, which can use to power your mobile devices. And this has got a very aesthetic look. It can be part of every educational campus. It can also provide shading also actually. So some work has been done, and you can see a lot of review papers. Even in fact, I have written a paper on solar PV tree review also. You can go through it. Later on, I'll show you all these concepts. There are a lot of work done on solar power tree. It can be act like a shading device also for charging, seating also in your campus. Then this one is about solar roadways. I think this kind of technologies are being used to generate electricity on the road. This also can be used to generate electricity to power your LEDs at the night time. The lights on the roadside can be used, and sometimes this heat is also used to melt the snow during winter. So this kind of roadways are being very researched in Europe. I think especially in Netherlands, this kind of roads are being tested actually, solar roadways, and it can be used to deploy large amount of electricity to grid also. Even to grid, it can produce that much of power. And major barrier, this is a advantage when compared to the land-based systems, because in land-based we use large amount of land, and which is not sustainable. So if you use these roads which are already being used, so convert this conventional road into a solar roadways. Therefore, this can be an alternate also, solar roadways. Solar noise barriers. So these days you will find on the highways, whenever you travel, it creates a lot of noise. Why don't we have a cost-effective noise barriers with the help of solar PV technology itself? And these noise barriers can produce additional electricity as well on the highways, and it can be like act like a fencing as well. Actually, it can act like a fencing, and it depends on the height, and it depends on the construction of the roads, etc. And also there was a research which is being conducted, and they found that east-west direction is best to place this solar noise barriers to produce more electricity. So this is one of the another interesting application. Solar PV satellites. You all know that this solar PV cells are being used in satellites actually to power for their emergency power requirements. And then solar space power is one topic which is also being researched a lot, because in solar in space you can produce more amount of electricity than on the land, because the amount of energy which is received on the space is comparatively higher than the amount of sunlight which you receive on the Earth's surface. So therefore, when you have a satellite, when you place a satellite into the orbit at around 3,600 kilometers above the Earth's surface, that can capture more amount of sunlight than the same area which we can have it on the land. Only problem with the transmission. So how you transmit this energy from the space into the Earth, that is through the microwaves, and then we need to have a cables to receive this energy at the ground. So these are the techniques. This is a technique, but it involves multi-junction or tandem solar cells with a lightweight material, which can be useful for satellite and military applications. Solar space power is also considered as a future source. Here the concept is, first you need to collect the energy with reflectors and mirrors. You need to have a large amount of mirrors spaced in orbit, which is capable of collecting energy. And then we can use wirelessly, we can transmit this energy to the earth through microwave. And then this earth can receive this through a microwave antenna actually. And the advantage with this space power is higher collection rate than the normal ground-based system, because these all solar systems are placed at the space itself, and it will collect more amount of energy than the land-based system. And it will have a longer collection period. Basically, the whole day it can collect than the ground-based system. And then it will have a better efficiency and all. But only thing is how feasible to send this energy from the space to the earth. So that is the challenge, and the cost involved in having this systems on the space is another challenge we have regarding to the solar space power. Then we'll go to the solar desalination. Why I'm talking about solar desalination is the solar electricity can be used to produce water also. Solar energy can be used to purify water, and with additional electricity from solar, it can be a hybrid solar desalination, in which we can use sunlight to produce water from the salt water actually. So this kind of technology is possible. So you see zero mass solar panels, which is being researched, where it will act like anybody who is having an air conditioner at home knows that air conditioner can produce water also, because during the process of refrigeration, air conditioning, we actually produce water actually from the air. It is like extracting water from the moisture itself, water from the air basically. So similarly, some researchers have developed a zero mass solar panel which can convert the sunlight into electricity, and this electricity can be used to produce water from the air. And they have found that roughly 5 liters of water per day can be produced with this technology. And there are some more research which are happening. One is another interesting application is solar PVT. So the solar cell efficiency is very less, which is around 6 to 15% only. So why don't we go for a solar photovoltaic thermal system, where you integrate thermal system at the backside of the solar PV to produce additional thermal energy, which will produce either thermal in the form, either air can be used or water can be used or nano fluid can be used. So nano fluid, water or air can be used to cool the panel, and this can produce additional heat energy, and this heat can be used for process application. In that way, we can produce heat, you can produce electricity from the single source, thereby the overall efficiency of the system can be increased. So this is a PVT system. Then we'll go to the softwares which are being used for modeling the performance of PV. There are different tools for that. So we will have a separate session to do the design and simulation, how to do the design performance evaluation with the help of these softwares. But just for information, I'm sharing only 3-4 softwares which are commercially used. PVSys is being used for modeling and simulation of utility scale solar power plants. PVSol can also be used. Homer Pro is very interesting for hybrid energy system. We can use Homer Pro. Red Screen is a very interesting one, and SAM, Solar Advisory Model, can also be used for modeling and optimization. It can be used to determine the feasibility of solar project. Before you put a solar project, you should know whether these systems are feasible enough, whether economically viable, whether it is feasible or not. For that, these kind of softwares are very much useful to determine the economic feasibility and technical feasibility of the projects. And as far as the performance assessment are concerned, we normally do the energy and exergy analysis. Energy analysis is based on first law of thermodynamics. Exergy analysis is based on second law of thermodynamics. Why we always go for exergy? Energy analysis is a very good measure for performance, but exergies should be always used for determining the quality of energy which is being generated. Why exergy should be used? Because it is a potential tool which determines the losses in the system actually. How much is the loss happening in the system? How much exergy, how much energy is being wasted? How much energy is destroyed during the conversion? You all know that during the sunlight process, sunlight is converted into heat or sunlight is converted into electricity. Through this process, some of the energy is converted into useful form, some energy is wasted actually. So this wasted energy we always call as irreversibility. The amount of energy which is not useful is always called as irreversible, which cannot be further useful actually. And this energy leads to exergy destruction, and we can quantify the exergy destruction during the exergy evaluation. Therefore, I always prefer using exergy analysis to evaluate the performance of system. You can use it for solar PV, you can use it for CSP, you can use it for any technology. Exergy and energy performance assessment is a very, very important tool to evaluate the quantity and quality of the system. And it can help to determine the losses associated with the system. It can help to assess the irreversibility associated with the system. Let us go to the next. Basically, for exergy, energy talks about first law, and exergy talks about basically derives from the second law, and it is related to entropy generation. It talks about degradation, how energy is being destructed, how energy is being converted, how energy is being used in this process. So basically, we'll go into this detail later on. So another 2-3 slides we'll end the session, and we'll take up very shortly. This last 2-3 slides I'm going to talk about the technological solutions which young people like us should research. There are a lot of solutions available, solar-based solution for rural India, solar-based home lighting systems, street lighting systems. Lot of street lighting projects are available, but only we need to come up with efficient systems with less maintenance, with a very good control system, long life battery, all these things. So home lighting system has got a wonderful market in the rural areas, especially in urban areas. Solar PV based handloom machines, rural women's and all. These days, these women, even today in COVID situation, we are trying to use the mask, and there is a huge shortage of masks. So we need a handloom for this production of mask. For that, we need a sewing machine, and this can be powered through solar based. So there are a market for solar PV based sewing machines. Solar PV based water pumping system for agriculture purpose, definitely there is a wonderful opportunity. Solar biomass hybrid drying, especially for drying the crops like spices, vegetables, cashew nut, all these precious crops. Biomass gasifiers for power generation. Biogas plant for cooking and other this one. Biomass briquetting for biomass cook stoves, improved cook stoves program already successful. A lot of biomass cook stoves are available. It can be a very good business opportunity. Solar PV based milk checking plant, cold storage plant, because these days farmers they produce cow milk at the rural areas, but this milk should be pasteurized, stored for a long time. So for that we need to go for a cold chilling plant which can be powered through solar. And then there is one interesting project on spirulina cultivation for women through solar greenhouse, because the spirulina is a microalgae which grows in a optimum condition. For that we need to have a solar greenhouse which can maintain the temperature of the spirulina at a constant level with automated systems and all. So these are some projects available for market and all. I'll just quickly skip through this slide. It talks about the impact of utility scale power generation on environment. Mostly each one of them we discussed, there is a lot of impact, that is mostly land requirement, cleaning, washing. The life cycle carbon emission, if we calculate, it may not be very much favorable. It affects the local ecology also, because CSP generates a lot of heat and all. So this we just discussed, but PV also has got a little bit of impact on because it uses a lot of land. Land footprint is the issue. Carbon footprint is not an issue, land footprint, because it occupies a lot of land. So therefore, that is a major problem with the utility scale PV plants. And in renewables, these are the options we need to do, researchers. How to enhance the efficiency of the primary converters. Energy storage device, what are the new storage devices, especially supercapacitors, ultra capacitors, microgrids, how to improve the efficiency of the end-use equipment, low wind turbine machines, thin film technologies, how thin film can be the future, then nano-based solar cells, nano composites for wind mills, nano-structured material for waste heat recovery, nano photocatalyst for hydrogen production, and this hydrogen can be used for power generation as well as for electricity for the fuel cell also. And fuel cell technology, through renewables. So far, the vehicle, I forgot to talk about the fuel cell vehicle, electric vehicle. The electric vehicle cannot be called as renewable at this moment because it comes from a conventional electricity. If it comes through renewable electricity, then we can say this electric vehicle is pure renewable. So therefore, I always feel that fuel cell route is the best if you talk about electric vehicle technology. First, you produce hydrogen and then use it in the fuel cell and then use it in your vehicle. So fuel cell based electric vehicle is a pure green vehicle compared to the electric vehicle which is being operated now. Then thermo-photovoltaic generation, TPV, is one future power which there is opportunity to do research. And there are other research which are very, very cost intensive, which we need lot of investment, lot of funding is needed. Such projects are listed here. Biogas operated thermophotovoltaic generator, low silicon materials, which with direct consumption below this one, thin film modules with efficiency greater than 10%, life more than 20-25 years, concentrating CPV, solar PV, CPV we call, low wind velocity wind turbine designs, the solar energy beam through satellites, solar for distillation, that is hybrid solar desalination systems, solar for cooling systems, solar for waste management, detoxification of waste, biofuels from algae, basically through the greenhouse, solar greenhouse route. So these are all some R&D projects with lot of investment needed. And currently, these are some of the topics of research for you. Solar desalination is a wonderful topic. Solar pond, solar dryer, evacuated collector, solar greenhouse, BIPV, BIPVT, building integrated photovoltaic technology, building integrated photovoltaic thermal technology, thin film technology, concentrated solar power technology, floating solar plant, dye-sensitized solar cells, organic solar cells. These are all upcoming field in solar field. In wind, it's all about design of the vertical axis and horizontal axis wind turbine, and how you integrate the wind with the solar power. So this is one system which we need to see the techno-economic viability of wind power projects. In biomass, mostly on gasifier to produce syngas, and then syngas can be used to run an engine, and biogas to produce cooking, and then microbial fuel cell or plant-based fuel cell for small power applications. In chemical energy, mostly fuel cell and hybrid electric vehicle. Hybrid electric vehicle can run through combination through the conventional fuel as well as through electric route. So this is hybrid electric route. Carbon capture and sequestration can be part of our area of research because all our power plants are coming through solar. So therefore, coming through conventional sources. Therefore, climate change, carbon emission reduction techniques in existing coal-based power plants should be one of our route. Artificial photosynthesis, green building, also a part of our energy research areas. All these, some are under fundamental research. I think some are under technological development, but industrial applications, I think still we are lagging in many of these areas actually. So I think I stop with this and I would like to interact with all the audience. Sorry for taking your time. I hope the presentation was useful to all of you. And I leave it to the organizers to have an interaction session with the participant. That's all from me, ma'am. Over to PSR Engineering College.
Okay, sir. Really wonderful and informative presentation, sir. We are getting so many positive feedback from the audience in the chat box. Some of the participants posted queries in the chat box and also raising their hands. Can you address them, sir?
Yeah, sure, ma'am. One by one, definitely, ma'am.
Okay, sir. Can you access the chat box or shall I read the question, sir?
Okay, I'll look into the chat also. So are we to talk with them? If possible, you can ask question directly also, no problem. You can mute
Mr.
them
Uma
and
Magesh.
you can ask somebody.
Yeah, sir. Mr. Uma Magesh Prabhu. Just wait a minute, sir. Shall I read the question, sir?
Yeah, yes, ma'am.
Yeah. So this question is from Mr. Uma Magesh Prabhu. When payback period is higher other than government, And big business people, I think solar power is not feasible for common man use, especially with today's economic scenario, except using in small power range.
Yeah, you are right. Actually, the person who has asked the question is very right. Especially with this COVID situation, definitely renewable energy, there will be a temporary setback. I agree that for a business people, especially investment, a huge investment is needed, and there is a market risk because of the raw material availability. Because many of our products, especially batteries or the panels or the components of the solar systems, are being imported from other countries. So there will be a supply chain risk. Many of the products may not reach on time, and this will put a temporary setback on renewable project development, especially large scale, and it is going to affect the payback to some extent. But as you said, maybe the distributed power generation, the small scale projects may be viable at this moment, provided we have all the products, everything available locally. Actually, if we are dependent on the components from other countries, definitely it will going to affect the economics and all. If all these products, especially solar photovoltaic material and the batteries and all the subsystem cables, accessories, everything should be locally available, and the transport supply chain should not be affected. We should not be dependent on, even for a small inverter, if you are dependent on another country, and then naturally there will be a problem for this commissioning of the projects in time. So therefore we need to ensure that all these products are available, the supply chain is there, and for this, I think this period would be for a small amount of time, maybe for another 6 months. Once this period is over, definitely I think renewables will again pick up, and hope for business persons like you, definitely again there will be an opportunity for us. You already know that how our environment has improved for the past 3-4 months because of there was a lockdown. So in the same way, this renewable energy will definitely help us in future. Of course, for the coming few months, there is a challenge. I agree with that. Yes, ma'am. Next. Yeah, I think there are a lot of queries.
Sir, Mr. Elil Moran Murugesan.
Hello.
Yes.
Yes, sir. Good afternoon, sir.
Good afternoon.
Sir, I am Edil Maran from Chennai Institute of Technology. I am working as associate professor. Sir, last year I have started one project based on the solar panel. So this is based on solar car, sir. You explained very nice. Your presentation is actually you are telling about solar, but your presentation is like a storm. Within an hour, it is really amazing. I am also having 20 years of teaching. It is an unbelievable presentation within an hour. First of all, because from the bottom of that, I wanted to thank you very much. And second case, when I am going for this car, when I am going for the normal solar panel, the size of the car will be increased.
Yes.
Because of harvesting the solar to electrical power. So for that, recently the research all over the world is going on. Even in NASA, we use maybe fiber optics. So with the help of the fiber optics, they pass the solar energy, and instead of directly expose the solar panel to the sun, they are using this fiber optics cable like a CD rack. They maybe arrange the solar panels one above and above, and then they place these solar panels on the rooftop of the car. So I have started this project. We did only for a miniature level, toy level car, because maybe the final year project I don't find the time. But I use some very small panels, maybe the 5 volt and milliampere capacity of panels. So that panel size is maybe 5 volt and 0.43 milliampere. I get 3 volt and some 0.2 milliampere only. So in that case, I need your help, sir, because you are really master in these solar panels. Can you help me?
Yeah, sure. Okay. Thanks for your query, Mr. Edil Moran. And in fact, I would be more than happy to see your model of your already started working on it, the prototype of it. As you have pointed out that there is a possibility of using optical fiber method of collecting the solar energy and utilizing it. Of course, you go with the conventional PV solar cells, it is going to occupy a lot of roof area, and which may not be good enough to generate enough electricity to power your batteries and motors. So this is a challenge we have. But however, you can optimize the energy through other routes. Maybe we can go for hybrid systems through energy generation through another route, especially like as I talked about fuel cell route or some other route where we can link with the solar come the other method. So that is a feasible option that is also can be tried. And with the latest advancement in solar cells, the size of the car and the structure of the car can be modified as well. It need not look like a conventional car model. It can be slightly different. It can occupy a different size. It can be depending on the size of the cells. It can be the shape of the vehicle. It can be modified also. In that way, we can structure the car in a different way to have enough collection efficiencies, and then we can develop the motor and batteries accordingly. So if we think about the existing car structure, that may not be good enough to accommodate enough panels, and it will be a little bit challenges there. I agree that there is a challenge with this development of solar car. And with the final year project, I think we cannot expect much with less amount of time for the students. They may not have time. They may have 6 months of time, and all. It needs they need to work for almost 1 year for this, and they need to come up with this. In future, if there is a possibility, we both can collaborate on this particular project. We can share the knowledge and expertise, and we can do it jointly also in future.
Thank you,
in
sir.
fact,
Thank
I
you,
also
sir.
gave similar project to my students, but they are unsuccessful in completing due to the time management and the availability of the material and all these things. We'll collaborate with you in the future, sir.
Okay, sir. Thank you, sir. Thank you very much, sir.
Thank you, Mr. Arvind.
Thank you, Lilmaran sir. Mr. Jagannath.
Yeah, yes, ma'am. Hello.
Yeah,
Hello,
sir.
sir. Hello, Sudhakar, sir. I'm from Telangana. My name is Dr. Jagannath. I'm Associate Professor in SGS Group of Institutions.
Okay.
Sir, my question is, why can't that transportation through car or something, it is not replaced by solar? That is my question. And I have also done the project on the solar bike. Solar bike means we have taken the bicycle and we have connected the solar panel, and solar panel is connected to the batteries is connected to that motor, PDMC motor. It is there, but we have tried a lot but we can't get the nice structure of the solar bike. And again, we are planning to do solar bike also. Is there any panels is there for not having huge amount of space? With the help of the small panels, we can fit it into the bike, like what bikes we are seeing now.
Yes.
We can make in future like that, sir. And my intention, being an electrical engineer, that every vehicle should be replaced by the solar. That is my question. Is there any suggestions from you?
Yeah. Okay. Thank you, Mr. Dr. Jagannath, for your query.
Okay, sir.
Thanks for your query. Basically, the problem with this solar PV for car application as well as bike application is the size and the solar cells which are basically coming from the frame and all. Why don't we go for a flexible solar panel? The flexible solar panel is something like which you can bend it, or which you can cut it, or which you can make it in a different shape. I showed a picture about solar tent, which involves a flexible solar panel. These days, there are some flexible solar panels in the market which are developed by Western countries, as well as the local Asian countries are developing this flexible solar panels. I think you can try with this configuration, come up with I saw some vehicles in Malaysia. What they do, very interesting. they are covering the bike with the shade actually, because here is too hard. So what people do, they just covering the bike with that shade. So they are able to get a shade for their car, so for their bike actually. So why don't we have a similar arrangement which will act like a shade, though it is not a car, it's a bike covered with a shade. Later on, I will share with you the structure of the bike in Malaysia. It is looking like they basically use it as a shade. Two people are traveling, husband and wife, or a kid is traveling, but they are covering with a small shade actually. So maybe we can come up with such a structure, like a flexible solar panel structure on the bike, and then can be used for enough storage of energy, and then can travel at least 20 to 30 kilometers with that charged energy. That may be feasible, I think. I will share you with our bikes which are present in Malaysia, so that you can work upon that design actually.
Okay, sir. Thank you.
Okay, thank you.
Thanks.
So good evening, sir.
Yeah, good evening.
Dr. School of Arts and Science, KVIT Arumudai Meedu. It is a part of VMR, Vinayaka Mission Research Foundation. So we are working in solar panel efficiency versus the intensity of the radiation. Say, may get the optimum temperature, at which particular temperature the efficiency is maximum. Then up to what temperature it will give the good efficiency, and how the intensity we have to reduce.
Okay.
So, an idea, sir.
Yeah, okay. Thank you, Doctor, for your wonderful question. So I didn't touch upon this particular topic. Actually, the solar PV systems are basically good at 25 degrees centigrade. There is a standard testing condition for solar photovoltaic panel, which they say as 25 degrees centigrade. And intensity something around 1000 watt per meter square. But normally in a practical conditions, the temperature, the ambient temperature will vary. It may reach even 40 degree, or at times it may be higher also. So therefore, the efficiency of solar cells comes down. The commercial solar PV modules, especially monocrystalline or polycrystalline solar cells, operate at standard testing condition actually. But in real life scenario, we cannot function at standard testing conditions. So it will be away from 25 degrees centigrade. Therefore, there is for every 1 degree rise in temperature from the ambient, it is going to, from 25 degree, it is going to be loss in the efficiency. It's almost 0.1%. We call it as a temperature coefficient. Each solar cell has got a temperature coefficient value. That much there will be drop in the efficiency. So we need to take care of that factor. For that, either you need to cool the panel, or either you come up with a hybrid system like I talked about, PVT systems, where you, to some extent, you can go for extracting the heat from the solar panel from the backside or from the front side, and you can cool it, especially on a hot climatic condition, especially during middle of the time, 12 noon. At that time, you can run this cooling system to reduce the temperature and try to maintain it. There are automatic control systems to maintain the temperature of the panel also, especially large utility scale solar systems. Once the temperature exceeds the optimum value, automatically we use a cooling system to circulate water to clean the panel. Like this, such systems are available. So we should ensure that the panel doesn't get heated. Once the panel gets heated, the life of the panel decreases, it undergoes degradation, and it results in lower efficiencies, hot spots and all. There will be quick loss in the efficiency. So therefore, that should be definitely taken care, especially in our country with too extreme summer. It will be a difficult situation. So we need to take care of that, sir.
So if I'm keeping the gap while the fabrication of the solar cell, inside that fabricated unit, if I'm posing any noble gases, is it useful for the increasing of lifetime and efficiency, sir?
Can you repeat it, sir? Can you repeat the question?
The fabrication, most of the solar panels, just a minute, sorry to take much time, sir. This is a solar panel. In this surface, if I increase the height of this panel surface, in between the defined portion noble gases, it will increase the efficiency.
That I'm not sure, because I have not studied about the noble gas effect on the surface. But what I would prefer is a lot of experimental studies with the water, with nanofluid, with other coatings are being tried. But the effect of noble gases on the surface, definitely we have not studied, but it's an interesting topic. We can think about it. But for cooling, I always prefer water or air or other nanofluids for cooling the surface. The effect of noble gas, I think it has to be studied, sir. We need to see what will be its effect. We'll take up as a research work, definitely.
Thank you, sir.
Dr. Sudhakar, sir?
Yes, ma'am.
Yes, sir. Some questions are in chat box. Shall I read?
Okay, ma'am, please.
Okay.
Should I read it or you are reading it?
I will read it, sir.
Okay, ma'am.
What are positive impacts of putting floating solar panel over a water body like ocean or irrigating dams, rivers, canals? Is it affect the water qualities?
Yeah, so it's a very wonderful question. As far as efficiency and power output is concerned, I already discussed that there will be 10% improvement in efficiency because this water is going to act as a cooling medium, and therefore it tries to maintain the panel at optimum temperatures. That is what globally research has been talked about, and it helps in cooling and improving the power output. As far as water quality is concerned, it is a because it's a difficult question. Water quality is either maintained or some to an extent it may get affected also, because this will act as a shading for algae and other microorganisms to grow beneath the surface. So therefore, if the water quality is so worse, it may get purified because of the growth of algae, or if it is a good water, it may get affected because of the growth. Actually, it is depending on the type of water it is. If it is a wastewater, and when you are placing it, definitely the wastewater quality is going to improve because the microorganism which grow will try to use the waste for its growth. But if the same water is a perfect good river water, then the algae may grow and then it may affect local water quality, because this provides a shading for microorganisms to grow. Especially there is a possibility of algae or other microorganisms to grow on these surface map. In that way, definitely there is a effect on the water quality as well.
Yes, sir. Which one is the best method of generating power from solar, either by using solar PV or solar thermal? Which method has higher efficiency? This question is from Mr. Vadivelan.
Yeah, very good. Mr. Vadivelan has got a very good question. Basically, it's CSP technology, and electrical engineers will be unhappy with my answer because PV is the electrical engineers as well as the policy makers in India. They are towards PV basically, but PV, as I told you, the efficiency is only 15 to 20%. Again, the commercial solar photovoltaic modules has got its own limitation, life and all. But you know, the thermal power plant, the coal-based thermal power plant, the life is around 100 years actually. So if you take a CSP plant, definitely the life of the plant is also good. It's quite comparable with the conventional power plant. The efficiency is also 30 to 40%. So definitely I would put my hands on the concentrated solar power than the PV technology. But why PV is preferred? Because of its simplicity. I can construct tomorrow. I want to put a solar PV plant, within few days I can construct it. But if you want to put a CSP plant, it may take time to construct it. That is the only challenge we face, and the cost associated with and other environmental impact. But if you want to simply compare the efficiency, definitely CSP plant efficiency is much better than the PV efficiency now.
Okay, sir. What is the maximum voltage fluctuation range allowed for low voltage and LV and MV due to variation in solar irradiation? This is the question from Rajesh. Shall I read it again, sir?
Please read it, ma'am.
What is the maximum voltage fluctuation range allowed for LV and MV due to variation in solar irradiation?
Yeah, actually, this one I think related to the IV characteristics of solar panel. If you can see observe the IV characteristics, there is an optimum temperature and optimum solar radiation to get the maximum power. So we need to see but we may not get the maximum power at all point of time. So we used to get only at one particular optimum condition. So that is at the standard testing condition. But beyond the standard testing condition, the solar intensity is varying, the ambient temperature is varying. When both the conditions are varying, definitely there is a change in voltage of a solar cell. I'm not talking about the array, I'm talking about only a solar cell. So for a single solar cell, definitely there is a effect of sunlight and effect of temperature on its on the performance. So this the squareness of the IV characteristics, we call it as a fill factor, and this fill factor will increase actually, will decrease actually. And if this fill factor is decreasing, then naturally the voltage and power output of the solar panel or the solar cell will decrease actually. So the squareness of the IV characteristics has to be maintained. For that, the optimum condition has to be maintained. If the squareness, if it deviates from the squareness, then there will be drop in voltage, drop in current and all. And of course, when you go for a large scale array and all this thing, it leads to the voltage fluctuations and all this thing. And I think electrical engineers know much about it, how to affect the harmonics and how to do all this balancing and all with the inverter, all these designs. That is taken care at the other side. But in a solar cell side, it needs techniques to make MPPT techniques and all to get the optimum power generation is being done actually. But there will be loss of voltage and current at beyond other than the standard testing conditions.
Yes, sir. This question also from Mr. Rajesh. Can I add
Yes.
reflectors or mirrors around the solar panel to increase the power to generate?
Yes, ma'am. Of course, I think interclimatic condition, when you don't get like December or some other season, when you get only diffuse solar light, that time you should have a mirror or reflectors to enhance the solar PV efficiencies. But if you do it on a hot, sunny climatic condition, especially extreme summer, you have a reflectors on an existing solar panel, it will reflect more of sunlight onto the panel. The panel may get damaged actually. It will be too extreme for the panel to take this amount of sunlight. So for that, we can have a concentrated PV technology, which will have filters, which will have other cooling systems to take care of it. For the existing solar PV, we may not have the reflectors on the normal sunny conditions. Definitely, it will be good to have reflectors in the winter climatic condition when we have only diffuse solar radiation. So this experiment can be tried during winters and see whether the efficiency is improved or not. Can be taken up as a project with reflectors.
Yes, sir. The last question, sir.
Yes.
Concentrating solar cell is used in the thermal power station. I think so as supplementary to produce steam as combined energy stores.
Can you repeat, ma'am?
Yeah,
concentrated.
Sir. Concentrating solar cell is used in the thermal power station. I think so as supplementary to produce steam as combined energy source.
Yeah, actually the concentrated, sometimes we get confused with the CSP and CPV. This is very contradicting term. So CSP is purely for producing heat and then electricity. It is called concentrated solar power, which is producing heat first. First we concentrate the heat, and then this heat energy is used to produce electricity. That is called CSP. Whereas in CPV, we concentrate the light to produce electricity directly. That is what we use in CPV. But again, the CPV will have a similar multi-junction solar cells with other cooling systems and all, with filters and all this thing. It's a complex device. It's not like a conventional normal silicon solar cell. It is a technology with so many other accessories, all this thing. So this is primarily meant for electricity generation, but with a better efficiency than the conventional silicon technology. That is what, as far as my knowledge is concerned, about CPV. CSP is through heat to produce electricity, but CPV is again through photovoltaics, but with the concentrated light source, with the concentrated mirrors and all these things.
Okay, sir.
Yes.
Shall I ask one question, sir?
Yeah, sure, ma'am. Most welcome.
Yeah, sir. You have discussed about both solid as well as the flexible solar panel. Is the power produced by solid solar panel and the flexible solar panel of same size, or it will differ? If suppose we want to design a solar powered electric vehicle, Which type
Yes,
of solar cell is feasible, either flexible or solid, sir?
Yeah. Actually, ma'am, in solid, the problem is the fixed panel. It has got with a metallic frame and all these accessories. We may not be able to bend it, or we may not be able to design shape. So one of the person also asked a similar question. There we can have a flexible panel, means it will help us to design the structure in a different way. For example, one person asked about a car. So for a car, if you have a flexible system, we can design it accordingly. However, definitely the flexible will have, we need more number of panels for same rating, because the efficiency is slightly lower than the multiple than the monocrystalline, because this flexible one comes with a different material. I don't think it comes with a pure crystalline. It comes with amorphous material. Therefore, the power output and efficiency is quite lower. So there, comparatively, we need larger size of panels for the if you go for a flexible solar panel. Flexible solar panel comes with other third generation material, which has got less efficiency. But it is good if you go for a different shape, or you want to make it in a different way. Then I think we should go for a flexible solar cell. So this will be useful for some other applications like solar car or the solar tent, everything. So in these places, I think we can use this one.
Thank you,
Yes,
sir.
ma'am.
Yes, sir. Shall we end up the session, sir?
Yes, ma'am. Okay,
No,
ma'am.
humble.
So,
Sir, I think you addressed all the questions raised by the audience. As the session is going in very interested manner, we didn't consider the time constraint also. I especially thank all
okay.
the audience for their patience listening, even though the time is extended. Thank you so much, sir. Just a
Okay,
minute,
ma'am.
can you please stop your sharing, sir?
Okay, ma'am. Okay. Thank
Uh,
you so much.
I want to give some intimation to the audience.
Okay, ma'am. Should I leave it? Should I leave?
Sir, just wait a minute, sir.
Okay, ma'am.
Okay, sir. Thank you, sir. Dear participants, we are going to organize another 1 week online FDP program in the area of research opportunities in electrical engineering applications from 18th May to 23rd May at morning 10 a.m. to 11:30 a.m. The corresponding registration link is provided on the chat box. The interested participants can register through this link. So the first 2 day sessions are carried out by Engineer B. Selva Ganesh, Electrical Project Engineer R&D, Total Plant from Kapalur. And the third day will continued by Dr. N. Karpagam from Velamal College of Engineering and Technology, Madurai, in the area of fax controllers applications in smart grid. And the third session is going to handle by Dr. B. Shakila, Assistant Professor of National Institute of Technology, Nagaland, in the area of cyber security in smart grid. And it is continued by Dr. M. Prakash on the next day, Assistant Professor, NIT Nagaland. The topic is Integrated Renewable Energy Systems. Yeah, and the last session is handled by Dr. G. Shivashankar, Assistant Professor of Tyagaraja College of Engineering, Madurai, and the topic is Sources and Origin of Power Quality Issues. And now I request Mrs. S. Krishnaveni ma'am, Assistant Professor of our department, to give vote of thanks.
Thank you, ma'am. Good evening to all. I am S. Krishnaveni, Associate Professor, Department of EEE, PSR Engineering College, Sivagasi. First of all, I would like to thank our Managing Trustee, beloved correspondent, Thru R. Solaisamy sir, and Director Engineer S. Vigneshwari Arunkumar Madam of PSR Group of Institution for giving permission to conduct a wonderful webinar on the topic of advancement in solar PV and thermal technologies for power generation. And I would like to thank our honorable resource person, Dr. K. Sudhakar, Faculty of Automotive Engineering Technology, University Malaysia, Pahang, Republic of Malaysia. I also extend my heartfelt thanks to our beloved principal, dean, HOD, and faculty members of PSR Engineering College, who have greatly helped us in organizing this webinar in a successful manner. Last but not least, I thank all the participants for their enthusiastic participation. Thank you, one and all.
Thank you, ma'am. Dear participants, we have already posted the feedback form. It is available on the chat box, so you can access through this link. Kindly submit feedback as possible. You will get the e-certificate immediately. Thank you, Nandal. Sir, shall we end up the session now, sir?
Yes, ma'am. Thank you. Thank you so much, ma'am.
Sudhakar, sir, thank you so much for being here. Thank you. Dr. Madhavan, sir.
Yes, ma'am. End, ma'am. End the session, ma'am. Thank you, sir.
Thank you so much, sir.
Thank you, sir. Thank you.
sir.
Thank you so much.
Thank you, sir.
So the session is going to end now. Thank you for your patience. Thank you.